Hello class, sorry I can't be there again today. Today we're going to talk about tangent lines and tangent rules and rules about chords as well. I'm probably going to be talking very quickly, so you might want to make sure you pause the video as I'm talking to make sure you get it all written down in your notes. So get your notes out right now and be prepared to start writing. The first rule is tangent line to a circle theorem. It says that in a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint on the circle. Remember, that's called the point of tangency. Now, that can look different depending on what you have in your picture. So this is basically saying that the radius and the tangent line are always going to be perpendicular. There will always be one radius that is perpendicular to a tangent line, and it makes a right angle. The radius and the tangent segment can make a right triangle. So for example, like the radius of the circle could be 5, and that tangent segment could be 12, and this segment over here could be 13, or a lot of other combinations. We also know that the diameter of the tangent segment will form a right triangle as well. So here's the diameter in the tangent segment in this line right here. This is going to pop up on your assignment for sure. The next rule about tangents is the external tangent congruence theorem. And it basically says that tangent segments form a common external point are congruent. So basically saying if you have two tangent lines, remember a tangent line just touches the circle in one spot. If you have two tangent lines that meet at the same point, that means that those two tangent lines have to be the same. So for example, if DC was 20, BC would also have to equal 20. And I could, if I wanted, put an equation, like I could say that DC equals x plus 5, and BC equals 2x plus 12, and you would have to figure out what the value of x is. Two very common problems you'll see. I'll do those tangent rules pretty quickly because I feel like they're pretty straightforward. A tangent line is always perpendicular to a radius, and two tangent lines are equal if they meet at the same point. But the chord theorems are sometimes a little bit tricky. So this is the main chord theorem that we're going to talk about. And this chord theorem kind of works the same forwards and backwards. It says if the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and the arc. So sometimes it helps to see it in pictures. If a diameter is perpendicular to a chord, then the chord is bisected. Whoa, whoops. Sorry about that. The chord is bisected, and the arc, so this arc from here to here, is also bisected. So the theme of this lesson today is really right angles, because we have right angles here, and we have right angles with the tangent line rules. The kind of reverse of this is also true. So if one chord of a circle is a perpendicular bisector of another chord, then the first chord is a diameter. So this chord is a perpendicular bisector of that chord, then this chord has to be a diameter. That's not really necessarily a very common rule. We're going to use this version of the rule a whole lot because we'll be able to do Pythagorean theorem with it. And in fact, let's do an example right now. So this one says, in circle A, the diameter is 12, CD is 8, and the measure of arc, CD, is 90 degrees. So first off, we always name circles by the center. So in this case, this is circle A. So the diameter is 12. So from there, well, that's going to be kind of hard to label. The diameter is 12. And CD is 8. So CD is this chord right here. And arc CD is 90. So based on this, we know several things. First, we can find, if we know the diameter of the circle is 12, that means the radius of the circle is 8. So any radius I draw in this picture is going to be 8, not 8, 6, because the radius is always half of the diameter. That's important to realize. So for example, segment AE has to equal 6. That's a radius of the circle, as well as BA also has to equal 6. We'll probably use this information a little bit more in a minute. So CD is 8. Since this BE is a diameter and it's perpendicular to this chord CD has to be cut in half to be 4 and 4. So I could say that CF equals 4, and I could say that FD equals 4. Now, let's do a little bit of thinking. Let's say that I wanted to find AF and FE. Those require me to do a little bit more thinking instead of just cutting stuff in half. Now, AF is this piece right here. And FE is the piece over here. Now, here's the trick, and you definitely want to make sure you write this down. If I connect the dots from A to D, I create a right triangle, which is super great. But I need to know the length of AD. Stop and think for a minute. AD goes from the center to the edge of the circle, so AD is also 6. So I have created a right triangle, and I can find the missing side of the right triangle. X squared plus 4 squared equals 6 squared. So x squared equals, x squared plus 16 equals 36. So x squared equals 20. And then x equals the square root of 20, which I could pop it in the calculator. You can get a decimal. I could reduce the radical if I wanted. This is the square root of 4 times the square root of 5, which is 2 root 5. And to find FE, all I would have to do is remember that AE is 6. So if I do AE minus AF, I'll get FE. And at this point, I would probably need a decimal, just because you really can't subtract the root numbers from the regular plain numbers. So whatever the decimal of 6 minus the square root of 5 is, would be my answer. Now let's talk about the arcs. Let's use this information here. Arc C to D. So from there is 90. Well, if you recall the rule says that if a diameter is perpendicular to a chord, then it bisects the chord and it bisects the arc. So this is 45, and that's 45, because half of 90 is 45. I could then, in turn, figure out the other two arcs in the picture, because that's a diameter, and a diameter measures 180 degrees. So 180 minus 40 is 135. And then conveniently, this is also going to be 135. I know we went through a lot of this really quickly. Feel free to email me if you have questions, and I will talk to you about this more later.